everyone. My name is Nishant from the ESP32 Millennium School, Coimbatore. I'm currently studying in grade 11 and my school recently has enrolled to the IITM School Connect program. And as a part of their courses, they have made us to do a little DIY project regarding electronics. And I have made this neat little robot car, as you see. It's a really interesting bot. I have named it Bridgebot. So let me talk more about what this robot car is, because it's not just an ordinary robot car. You can control this using an internet connection, using your phone. So I think that's pretty cool. So let me talk more about the components of this project. So as you see, for the main power source, I'm using 3 lithium-ion 18650 batteries, which will produce around a total of 12.6 volts. I have a switch over here. So the reason why I have a 3-way switch over here, it's not the normal 2-way switch, is because I want to be able to charge my batteries without powering my load. So the charging circuit is a little bit inside, which I cannot show you at the moment. But anyway, that doesn't matter. Let me get you to the real source of this car. So as you see, right inside that board you see right there, that is the L298 motor drivers. So these drivers are the ones that control these 2 BO motors, and there's also one more in the front, which is covered right now. And these inputs from the motor drivers go directly to the heart and the brain of our bot. So this is the ESP32 dev module. So the ESP32 dev module is such a powerful board. It has 2 cores. So I have decided to take this board to the max by adding some very special functionality, such as streaming gyro data from my phone over to this board for it to control itself. So let's talk about the wheels over here. So I had 2 options. We can either choose from a mechanical wheel or the normal wheels. Unfortunately, my mechanical wheels never arrived on time, so I had to go for the normal wheels. So yeah. So let me talk more about the structure right here. Right now, I just want to say that it's not very structurally integral. I do have some problems about it not being fully flat, not all the wheels touch the floor evenly. So there are some issues. But notice how it's built like a truss bridge. So that's why I named my bot the Bridgebot. Unfortunately, it's not as strong as the actual truss bridge, because that's what happens when you build using popsicle sticks. That is my entire car. Let's get into the code, shall we? So as you see right now, I am in the Arduino IDE. So I have used the Arduino IDE to code the ESP32. So now we have to go through the startup process of setting our Wi-Fi credentials. So I have set my access point at my laptop. So once you plug in the board, you should see this sort of Wi-Fi setup. Enter Wi-Fi SSID, and I can enter mine. So I can just enter it through the CD monitor, and I can enter my password as well. Once I have given everything, it should be able to connect as soon as I turn my hotspot on my laptop. As you see, it has connected. If we go over to here, you see that the web server has been initialized. So once we have fully connected to the internet, we can disconnect the USB cable. Now all we have to do is to enter this IP address into here to our web browser. Let me talk more about this Bridgebot interface right here. So this is the interface that's going to be sending gyro data from our phone to the ESP32, and the way it does it is using WebSockets. So WebSockets is a technology that lets us send real-time information over the internet, which I have used over here. So as you see, there's a level in the center that adapts to what the position of the phone is, and if I press it, it goes active. So it only moves when I press it on the screen. So once you're here, all we need to do is to press the connect button, and as you see, it's connected to our bot. All I need to do is to hold the phone and slowly move forward. As you see, the wheels move. And the interesting thing is, depending on what position I hold my phone in, the wheels will move differently. That will help us to turn. For example, put it dead center and tilt it forward. You can see all the wheels are moving in the same direction so that it can move forward. Similarly, I can go backward, and if I turn like this, it should be able to spin around. You see these two wheels are spinning in opposite directions. Can help it to spin, and similarly for the other way. And if I hold it in the northeast or northwest direction, it only controls a certain set of wheels so that it can turn. I do want to say I'm currently experiencing some structural issues. It's not fully sitting on the floor, so it won't be able to turn or anything, but it'll be able to move. So I have the bot put on the floor right now, even though it's not fully structurally correct, but I just want to show you how it all works. So as you see, all I need to do is to center it, calibrate it, and hold. I can gently move it forward and it will start moving forward, or not, because it is not structurally integral, so it starts moving over to the left. So in the future I am looking to fix that, but overall I have had a lot of fun building this bot right here. I have spent various countless nights designing this, planning it, coding it. Hope you guys like the video, and I will be posting a full video on my channel and hopefully posting the GitHub code as well. So this is going to be a fully open source project. You can also build it if you want. It's really simple. It only costs around 1.7 thousand rupees or something for the entire package. You'll be learning some new stuff. You'll be learning about how to use WebSockets, how to set up a web server locally inside your own router, inside your LAN, and some basics about web development. Yeah, I have had a lot of fun building this project. I would like to thank the IITM School Connect team for giving me this opportunity. Looking forward to attending more of these sort of DIY projects. So yeah, thank you guys a lot, and I'll see you next time.